Alright, back in the day we talked about finding the area between two curves. So if we wanted to go, or the area between a curve, I should say, what we did was if we wanted to go from 0 to 2, the area under a curve we could do by evaluating an integral like so, and then plugging in with the definite numbers 0 and 2, and we would get 8/3 as an answer. Now, something that we can do now, though, is let's say we have that same quadratic, y equals x squared. Let's say we have another function like that, and we want to know what the distance is between those two curves, what the area is in here. Well, to do that, all we would really need to look at is if we look at what the area was from where they intersect of what's under the linear equation, and then subtracted what was extra from the yellow from the quadratic equation, then I would have what's left here in blue as my answer. So what we are using here is a formula to find area between two curves. Is if we have a function on top, which in the last case was the linear, and a function on bottom, all we need to do is to subtract those two functions and take the integral from where they intersect. A and B are the intersection points of the graphs, and that's how we get the area between two curves. So to show an example, here's the first one. Now, they won't always give you a graph, but usually they will, especially if it's a problem like this. What you would normally have to do is to find the intersection points themselves. In this case, they're telling you what they want to look at. So, from 0 to 2, so that means my limits are 0 and 2. Now, how do you know which one is on top, especially if they don't give you the function? Well, if it's between 0 and 2, well, let's plug in a number between 0 and 2. The easy one to do would be 1. If I plug in 1, what's bigger? 1 squared plus 2 or negative 1? Obviously, f of x is bigger. So that means I need to do x squared plus 2, and then subtract the bottom one, which is negative x. Subtract negative x means the same as adding another x, dx. So now, we just evaluate this integral. So, that means I have 1/3 x cubed, 1/3 x cubed plus 2x plus 1/2 x squared. And this is evaluated, it says, from 0 to 2. So now, what we need to do is we need to plug in first the top number, which is 2. So 1/3 of 2 cubed, which is 8, so that's 8 over 3, plus 2 times 2, which is 4, and then plus 1/2 of 2 squared, so that's plus 2. And I would need to subtract everything if I plug in 0. So 1/3 of 0 plus 2 times 0 plus 1/2 of 0. Well, this thing here, the bottom one is going to become 0 because it's just plugging in 0. To find what these are, I would have 8 over 3. I need to make these over 3. So that'll become 12 over 3. And 6 over 3. That means I'm going to have 26 over 3 minus 0, so my final answer is 26 over 3. Alright, let's look at another example here. In this one, after I've already given you the answer, in this one, if they give you a graph or they let you use a graphing calculator, you can figure out what these points are by using your intersection keys and everything like that. And I believe it's -2 and 1. But here's the thing, what if it's the non-calculated part? How can you find where they intersect? Well, where they intersect, that means where they equal the same thing. So all we're going to do is set them equal to each other. 2 minus x squared is equal to x. Well, let's get everything on the same side of the equal sign. X squared plus x minus 2. How do I solve that? Well, let's factor it. Factors of 2 that subtract give you 1 would be 2 and 1. The 2 is the positive, the 1 is the negative. That means that x will equal a -2 and a positive 1, like we said. So that means I can now set up an integral from -2 to 1. Now what's my top function? Again, I can plug in, well, I would say from looking at this, the quadratic must obviously be the one on top. However, I'm going to look more based on what the functions are. A number between -2 and positive 1 is 0. What's bigger, 2 minus 0 or 0? Obviously the 2 minus 0. So I'm going to do 2 minus x squared and then subtract an x for the bottom. So top minus bottom and then dx at the end. So all I can do, I'm already in good shape, I can take the antiderivative. 2x minus 1/3 x cubed minus 1/2 x squared. And I need to evaluate that from -2 to 1. So first, if I plug in my -2, I'm going to end up with I want to plug in 1 first, my top number. So 2 times 1 minus 1/3 times 1, which is 1/3. So I really have 2 minus 1/3, and then the last one, minus 1/2 of 1, so minus another 1/2. So this is the same as saying that would be, see, what would my common denominator be? It would have to be 6. So I would have 12 over 6 minus 2 over 6, and then minus 3 over 6. So I get 7 over 6 for my top part. Now, when I do the bottom part, and I plug in negative 2, 2 times negative 2, which is negative 4, I'm then going to subtract 1/3 of negative 2 cubed. So that means I'm going to add an 8 over 3, and then when I plug in negative 2 and square it, I get positive 4, so I'll have a minus 2 when I take negative 1/2 of that. Common denominator here is going to be 3, so negative 12 over 3 plus 8 over 3 and minus 6 over 3. That means here I get a negative, this should be 12, 18, so negative 10 over 3, which is the same here. I'm going to make a common denominator between these. That means this is a now going to be a negative 20 over 6. I need to subtract these two values, these two answers. That means I get an answer of 27 over 6 for my final answer there. 27 over 6, I'm actually going to see if I could probably reduce that. Divide by 3, both top and bottom, so 9 over 2 ends up being my final answer for this.